This video is all about electrolytes. Electrolytes are compounds that ionize in water to produce aqueous solutions that can conduct electricity. Many of us have heard of electrolyte solutions in our everyday life. You know, um, Products like Gatorade or Powerade are marketed as electrolyte solutions to replace lost electrolytes in physical activity. Liquid IV and various other electrolyte drinks, whether they're sold as powders or like already in an aqueous solution, are really popular. And not surprisingly so, we do need electrolytes. Whether or not we need to drink as many of the drinks that are popular, I'm not sure. But there's certainly a time and place for them in, times of really strenuous physical activity or when we're really out in the heat and we are sweating a lot. Those are good times to replace those electrolyte solutions. So, non-electrolytes are substances that do not ionize. They remain as intact molecules rather than ions when they dissolve, which means that solutions of non-electrolytes do not conduct electricity. In terms of chemistry, certain categories of substances are electrolytes, and so this is shown here below. By the way, when we're talking about electricity, we are talking about the flow of charge, or just, we can write this as just like moving charge, moving electrons. We're talking about flow of electrons. So we're just talking about the ability for charge or electrons to flow when we are talking about electricity. Okay, so electrolytes are things that do ionize when they dissolve in water. All the ionic compounds are electrolytes. So think salt, for example. Table salt, NaCl, breaks up into Na plus and Cl minus, and each of those ions can conduct electricity. What about something like magnesium chloride? Well, that's MgCl2. That can break up into Mg2 plus, and it will make two of the chlorine ions. So there'll be two chlorides for every magnesium. In other words, there'll be an Mg2 plus, and then there'll be a Cl minus, and there'll be another Cl minus. So all of the ionic compounds are electrolytes. All acids and bases are electrolytes. So, what's an example acid? Well, let's just say we have HCl. That will break up into H plus and Cl minus for electrolytes. What about a base like NaOH? Sodium hydroxide will break up into Na plus and OH minus ions. So they'll break up into their component ions. So acids, bases, and ionic compounds are all electrolytes. They break up into positively and negatively charged ions, and these can conduct electricity in solution. Non-electrolytes are things that do not ionize when they dissolve in water. They don't conduct electricity when they're dissolved in water, and all covalent compounds except acids and bases. So generally speaking, covalent compounds, think sugars, for example, they don't break up into ions and so therefore are not electrolytes. So notice that identifying a substance as either electrolyte or a non-electrolyte does not predict whether or not it will dissolve. It only predicts whether or not it will ionize if it does dissolve. So if it dissolves, does it form ions? And so the ones that, when dissolved, form ions are the ionics and the acids and the bases. But of course, some ionic compounds don't dissolve. So this doesn't predict if they're going to dissolve, just if they're going to make ions. So in summary, all ionic substances are electrolytes. All acids and bases are electrolytes. Covalent substances, except acids and bases, are non-electrolytes. So most of the covalents, non-electrolytes. So what do we mean by ionic? Well, we mean that there is a cation, a positive metal cation like sodium, and an anion, a negative anion like chloride. So cation, metal, or it could be polyatomic. It could be ammonium, could be NH4 plus. Anion, a non-metal like chlorine, or a polyatomic ion, and there's lots of options for negative polyatomic ions. Covalent substances have only nonmetals present. They don't have any polyatomic ions or any metals, and then they're going to be non-electrolytes. So electrolytes we know are critical components of human blood plasma, where they're involved in functions like electrical activity of the heart and operation of cells. Electrolyte imbalances serve a diagnostic role. They can really be indicators of medical distress, and severe electrolyte imbalances left untreated can actually be fatal. So again, we've heard about these drinks like Gatorade, Powerade that have electrolytes in them, and these are really important. For example, we know that sodium is really important for maintaining osmotic pressure. So we're going to talk more about that, but maintains osmotic pressure. We know that potassium, sends signals in nerve cells and muscles. So let's just write signaling in neurons and muscles. And then we know that magnesium is important, especially in enzyme regulation, and that calcium, is really important for muscle contraction. So lots of important roles for each of these electrolytes. And so let's just look a little bit more at a picture of dissolving, just to better understand what's going on. So when an ionic compound dissolves, such as sodium chloride, each little Na plus is pulled off of the main crystal by being surrounded by water. So the positive sodiums are surrounded by the negative oxygen ends of water and pulled off of that salt crystal. And negative chlorine atoms are surrounded by positive H's of water, pulled off of that salt crystal. And they're pulled off one ion at a time. So these ions are separated, off of the main crystal, and these individual ions are what's going to conduct solvated ions, or what is going to conduct electric current. In sugar, now it's hard to see, but in here is a sugar molecule. It's getting surrounded by water because it's got lots of OHs that make it water soluble. But the sugar is staying as one big molecule. So these are molecular compounds. They do not dissociate into ions because they're not made of any ions. They stay as one big molecule. So there's nothing to conduct electric current. So this one's going to be a non-electrolyte because there's nothing to conduct electric current. And here we have an electrolyte, an electrolytic solution that will conduct current. It's these individual ions that have been solvated that can carry that flow of electric charge or current, and the sugar just will not, doesn't have any ions to carry that current. So let's look at some examples of electrolytes and non-electrolytes. What happens when sodium chloride dissolves in water? We get Na pluses and Cl minuses, and that would be an example of an electrolyte. Double the concentration of sodium and chloride ions, and again you'll have an electrolyte just at twice the concentration. So electrolytes, again, these are the ones that break into ions. let's just write that, like sodium chloride. And the non-electrolytes do not. So these do not break up into ions. So these are covalents that are not acids or bases. NaNO3, sodium nitrate, well, that's going to break up into Na plus ions and nitrate ions. So that one is going to be an electrolyte as well. C6H12O6, we've got sugar here. It all stays as C6H12O6, so that's going to be like glucose, I should say, not sugar, but glucose, and that one's going to be a non-electrolyte. So that one will not be because glucose is covalent. Okay, calcium chloride, Ca2 plus and Cl minus ions, that's going to be an electrolyte. We've got ions to conduct electric current. Here we've got methanol. This is an alcohol, CH3OH, and it's staying together as one covalent compound. It's not an ion, so this is a non-electrolyte. It will not conduct electric current. Then we've got ammonium hydroxide. Ooh, that's a base, actually. That hydroxide is a sign of a base. And so even though you might go, well, these are all nonmetals, nitrogen, hydrogen, oxygen, hydrogen, all nonmetals, you might be like, I don't see a metal there. How could it be ionic? Well, it's a base, and it's breaking up into hydroxide ions and ammonium ions. So that one is going to be an electrolyte. Because of these two different polyatomic ions, we're really recognizing there's one polyatomic ion and there's a second polyatomic ion. So it's breaking up into these two different polyatomic ions, the ammonium and the hydroxide. So that one's going to be an electrolyte. You could say, it's due to the polyatomic ions, or you could recognize that, those are basic polyatomic ions, and so then it's an electrolyte. How about copper chloride? You've got metal copper ions and chloride ions. That one's going to be an electrolyte, breaking up into ions. Magnesium phosphate, same thing. Magnesium ions, phosphate ions, that one's going to be an electrolyte. So we want to be able to predict if these are ionic or covalent. We do also want to be able to predict how many ions are formed in these solutions. So for example, with magnesium phosphate, it's important to be able to predict that, hey, Mg3 means that there's 3 of these Mg magnesium ions formed, so 3 magnesium ions, and that there will be 2 phosphate ions formed. It's PO4 3 minus, but there are 2 of those ions, and then there are 1, 2, 3, 4, 5 ions total. And so those 5 ions are going to be important in our next discussion of osmolarity. The number of ions formed is important as well. More ions really mean for a better electrolyte, or more ions to conduct electric current. So this concludes our discussion of electrolytes and non-electrolytes.